In this episode of Finnugric Machine, we are finally making the top plate for this cycloid drive. I will be using this. This is some mild steel. It used to be a 70mm shaft. I cut a piece from that, that's one. And this is going to be the final product. But since this has some difficulties in holding it, especially in the dividing head, which we are going to use, I need to make a mandrel. And it will be attached here, and there will be this is an exceptional mandrel in a way that it will stay there. It's not going to be removed after this piece is ready. So I will actually put it there using threads.
Forget about the threads. Just glue it.
And then glue it in place with the threads. It will be cut off. It will be like this, and after it's ready, it will be cut off, and this will then become the top side of the thing. But yeah, okay. So the first task will be done in the lathe. We start here by the lathe by making the mandrel first. Well, it's a very simple piece of thing. This is 20mm cold rolled mild steel. Well, it's surprisingly accurate. The diameter is 20mm and it's about 300ths of a millimeter to undersize. Well, it's exactly what we want. So let's chuck this piece. I will put it here, wiggle it as always, and well, I will just face this end. This is the end which will be chucked, and I will face it first. It's very simple operation. Just facing tool here. Remember to tighten it. Too often I forget to do that. A lot better. And because I'm going to file here, I will clean the environment so that I don't file myself. And now I just, this is just an ordinary file, and whenever you file in a lathe, handle. I like to have a round corner there so that it goes nicely into my collet, because this is going to be the final thing will be done in a collet. I extend it a little bit like that, quite a lot actually. I want to give it a bare tongue treatment. Well, now it looks shiny and nice. Okay. Now the other end can be done in a collet. I just wanted to have a good surface so that this kind of surface we have at this end, which is has remnants of angle grinder. It's not a very good idea to stick this one into your collet. Well, this one is a better choice. So now I will switch off the lathe because I'm going to change the chuck. And then, because I aligned the knots with that one, I already know that this should go in this way. Now we can put the... Okay. And where was the workpiece? Ah, there. Okay, now. This is like that. Oh! Yeah! Well, you should be careful with this. Oh man. And switch the lathe back on. And go to the high speed mode. Well, yeah, there you are. And now we continue with the same operation. We face it, and then I need to go here and fish the high spots. About there. Okay. And now I face this side. So far so good. So we have a pin 20 millimeters thick and something long. The length is not important in this case. So the next thing, I would like to turn this down a little bit. I don't want to have it like 20 millimeters. And furthermore, I would like to have a shoulder here where the workpiece can rest on. So we take this down to 10 millimeters, and the distance we are taking it down to 10 millimeters should be about... This is the actual workpiece, and the distance should be... Well, here we have like 17. Well, I think 18 millimeters is okay. Because this doesn't reach all the way, I know already. I have to move this about the maximum it goes. It's easier for me. The compound, I mean. There you are. I'm going to use that insert. That's very sharp and it doesn't introduce too much cutting forces. So now I will move the carriage so that it touches this surface here. That's there now. And then I will lock. Here is the carriage lock. I will actually lock the carriage here. Like that. Then I will move it back away from that, so that I don't damage that one. And now we have a nice feature in this lathe. Namely, I installed this ARO recently. So I will now reset that one. This is the first time I use it actually for something. Okay, now it's there. I can now unlock my carriage, like that. And then we needed 18 millimeters. 18. So, that's 10 millimeters. 18. There you are, 18 millimeters. Lock the carriage again, so I don't lose that place. And then, since the carriage is now locked, here is our carriage stop. I put it against this thing here, like that. This is the carriage stop. So when the carriage moves towards the headstock, it will stop here. And there is a ratchet mechanism inside this thing which makes it so that it doesn't damage the lathe even though it's a hard stop. So now what happens, I can check this by loosening now the carriage again. And let's see, now we have here 18 millimeters. So let's move back and go back there. It stops to 18 millimeters. So now the resulting thing is that we get 18 millimeters here, like peeled off. And now I don't need to worry about when to stop the carriage. I can use the feet. It stops automatically whenever I do this, and now I can take care of like the diameter, which is actually quite important here. And the cut is 0.5 millimeters, meaning 0.25 millimeters per side. Let's make this really accurate. So, and the surface finish is really good. We should be now 10.25. Well, we should be. We are 10.24. Okay, that's okay. So, that's the last pass. Okay. We are now there, and I didn't disengage the feed. So the feed is now on. It has been pushing itself towards the workpiece, and now the tool is there. The tool is there, like in the workpiece. I will lock the carriage here. Like that. Now the carriage stays there. Then I can disengage this, and then I unlock the compound like that. And what I will do next, I will actually feed in here just a little bit, and then I will face this surface. So let's do that. I will restart this. It should do nothing, just rotate there. But now I feed with the compound a little bit. Like there. And then I feed by hand, coming out from there. And there you have a very, very nice shoulder. Yeah, Chuck. Yeah. Okay, I already lost. Okay, I need to do this now again because I succeeded in this one. So that is one. I have here like dimples. This one is one, and that's two. That's number three, and that's one. Well, since it's now out from there, so I will actually do some cleaning for it. Yeah. So, and which one is the one? That's the one. Well, that one is one. That's one too. So we need to put these back. So when I turn this here, at some point, as you can see, there is the start of the spiral. Okay, so I put it back there like waiting for me. And then when it's waiting for me there, I put my first jaw here and put it there, like that. And then I turn this a little bit and there you are. Next jaw. Oh yeah, you can see this. So I turn this until I see the start of the coming there. And now since we had this is number 3, so this is number 2. Well, it's a very good idea to mark those in the chalk, which one goes to which. You could mix them if you wanted, but that would. So now when I turn this just a little bit, now it's past the first one. And then the last, same story. I will turn here until I see the spiral coming, and then I will clean this and put my jaw there. This was, well, these are a little bit, okay now. And now what should happen? They should meet in the middle. If not, I did it wrong. Yeah, they meet. So now I need to turn the jaws. I switched these to low gear, so then we just open these. It's very easy. Just take away the hex bolts from there. This should be somewhat tight. They are like that. And then again, I get rid of any dirt in there and here. Okay. And then I just put this here, this way. And now these bolts are of different length, so you have to pay attention to put them in correct place. And then you just screw them back in. And the next. Okay, now this should be more feasible. Yeah, okay. So actually, which side should I put there inside is the flatter one this time. And again, wiggle it a little bit and there you are. I can see that we have some remnants from my cutting operation here, and I would like to get rid of them. I don't want to destroy my lathe tool with these. I just file those away. Those kind of things near the center can really destroy your facing tool easily. Tilt this a little bit like that, so then I don't accidentally stumble into the tool with the jaws, these jaws that are sticking out from there. So, then we also have here one thing that I would mention. I won't face it all, just the center, so that I can start, so that I can drill a hole there. That's the reason being for that hole to be drilled as early as possible is that the cutting speed of this tool is really slow when it goes to a point. Actually, it's almost zero cutting speed, and that can break your tool quite easily. So let's touch. Well, again we have here a construction kit. So we have the reamer, and it has a Morse 1 cone. Well, now it's Morse 2, and now it's Morse 3. There you are. And I first make a spot there. Something for the drill to start from. Okay, that's enough. And this drill is a Dormer. It has a split point, so it should be quite easy to drill with this one. Let's see now. Reaming will be done with low speed, and this needs a lot of lubrication. See, it's not straight. I mean, not. But it doesn't need to be in the center, really, no. But what it does need to be, it needs to be, well, let's say exact round hole. I could, well, like, drill this, but I mean bore. Now, let's see, there we are. Well, done. Wow. Well. Oh yeah. And this also had some cutting fluid in it. Not that much anymore. Yeah. I turned the machine off. There you are. Now this surface is, it's good. It's not perfect. It has, well, you can feel it, but it's okay. And then, well, that's okay. Now I will turn the outer diameter. It should be 65 millimeters, about. It's not exact science how much it is. But, well, it's a visual thing. So, if I get it near to 65 millimeters, then it matches this outer diameter here. It's going to be placed on top of this here. And now I'm taking 0.25 millimeters from the diameter. But I'm feeding it 0.1 millimeters per revolution, so that should actually break the chips. And then the speed is around 400 RPM, not too fast. Let's see. Let's see if I can grind this. I did grind this in my CBN wheel, and now let's see if this surface becomes any better. It's really horrific. No, the surface actually is quite good, but this here on the back side reveals that it's not really sharp. So let me try this. So let's take like that and see how it does. Did it make any difference? At least the sound is very different. horrific pull from the backside. Well, it didn't. Yet. Well, it's about to fall off. Yeah. Okay, and this you don't pull like this, you take your pliers and pull it off. Oh yeah, okay. Well, and the surface is even worse. This, you can, I think you cannot feel this, but I can tell this is not a good surface. I will change that insert. That's now. My grinding was not very successful, I think. Well, maybe we can rough it with this one. How much do we have left here? If I go to 65.5, yeah, we have exactly now 67. So I will take, let's take 0.5 millimeter cut, but with very low feed. That also can make a whole difference. You can tell that it's not working properly. It shouldn't be doing that. Let's see now how. I will now change the insert. Press insert, and now we hopefully I get better surface than this. Well, now I'm peeling off only 0.25 millimeters here. You already can see that it's a little bit different. Well, you can still scratch it, but well, it's way smoother. And now I will take next 0.25 millimeters. So let's measure. Oh man, it's good surface. There you are, 65.18. Yeah. So this is the last pass. Now let's see. How close did we get it? Well, it's a little bit oversized, I think. It's something like maybe 200 oversized, depending how you measure it. Yeah, but that's close enough. Before we can go on with the turning that cover plate here, we need to take some measurements here. Lid comes on top of this, and there are these pins which have a place for a screw. So the intention is to fix it with these screws there on top, so it holds it in place. And then we have this thing there, which is there in between like that, and these are a little bit proud here, so that it has a room to be there. The interesting figures here is the first of all the inner diameter of this here, this diameter. That's one thing that is interesting. Another thing that is really interesting is the height from this top here to the pin top. So we need to, because there will become, if you think about the lead, it will be like this. And then we have the cap screw here somewhere coming through. And then this piece is going to rest like this here. So we need to know this distance in order to make a recess into our lead. This recess here. So it's like this, and the first thing we need to know is this distance. How much is this? And then we need to know the diameter of that thing. Those two. So snap gauges. Is that a good one? Seems like. You should put it a little bit tilted like this, tighten it, and then draw it. Okay, it might have the correct figure or might not. We will take several measurements here. I'm wiggling it here until it comes in contact with that point. I'm not using the ratchet in this case. Okay. I think that's our figure, and it seems to be 55.90 98. That was our first measurement. I'll write it down here. $55.98. And let's take another. You have to tighten it. So it was 55.98, and now we get right there. 55, 56 exactly. Okay. So now we get a little bit less, quite a lot less. 55.94. Well, I reject that one. Let's see that one. Well, now it's now it looks like it's 56 again. Okay. So maybe we can assume that it's 56 millimeters. Means that I want to have some room there. So what we are going to make that diameter is 56.05.
Shouldn't that be the other way around? That would now create a tight press fit. So the correct dimension might be something like 55.95.
I think that's a reasonable value for that. The next thing is that depth. I'm very bad in reading these, so now it's 5. 5.5. 6. 6.49. Made a mistake here. That figure, 56.05. So I would have made it larger, than the smallest diameter I measured. Means that it would be that one. It would be really tight. Actually a press fit. So it should be smaller actually. So 55.95 is what we probably aim to with the diameter. And the depth was alright. So 6.6 is what we aim to. So now I'm going to set up accurate depth here. And first of all, let's switch this on. I have locked this. This is the carriage stop. I have locked it. It's tight and in place. And I will engage the feed here. And I will drive it against the stop now. You can see it's no more turning that way. So now it's against the stop. Then I stop the lathe and lock the carriage here. There it is. And then I can disengage the feed and I will touch that surface now. Let's see now. Well, okay. So now we know that this blade is now exactly on the surface near that one. And the carriage is at the end of travel, where it goes before it strikes the stop. So first I will unlock this and then I will move the compound, the required amount, which was actually 6.6 millimeters. Here, 6.6. I would like to, even though I would like to leave something for cleanup, so I will move it 6.55. 6.55. Okay. So one turn here. That was 3. That is now 6 millimeters. Then this is 6.5. 55. So this focus is not very good. This really amazes me every time how bad it is. So 55, there you are, that's the one we want. And now I lock this. And now I will touch this outer surface. Turn this against the stop as many times as required and it will be 6.5 millimeters deep. We have 10 millimeters, almost 10 millimeters to take away from the diameter. So at the moment it seems like it's 58.01 or 0.2 maybe. Well, yeah, okay. Well, 56.22, and our goal was 55.95. And this is our last cut. So. And yes, I left it intentionally into there now. So now the next step is to lock the carriage here. It is now pushed against the carriage stop, but I lock the carriage here, disengage the feet, and now we had 0.05 of a millimeter more spare. I will beautify this face, this little ledge here now. So I will turn the ledge back on. Feed in the 500s here. Like that, and then manually take it away from there. This should clean up the surface. There you are. The tailstock is pushing this quite heavy piece of metal here, and then we have these, so it's actually pushing the pins there inside, and yeah, this is moving freely. It has a little bit of play in it, and it's okay. Sideways no play, but axial play, that's totally okay. And this is just to create an optical illusion of professionalism here. So. Now we have a very good optical illusion here. Next, I will put this one into that one. Yeah, okay. Next we will shift the table to the bolt circle diameter, if my memory serves me correctly, is 35 millimeters. So we have to move the table half of that. Actually to any direction, like that way, this way, down, up. Not this way, because this is the drilling direction, but I will move the table, it seems like that way. Okay, so my memory served me correctly, and the bolt circle diameter is 35 millimeters. And half of that is 17.5 millimeters. So let's move this 17. This is the y-axis of this mill. So 17.5 millimeters. So 1.7 millimeters. That's 1 millimeter. 1.75 times 2. 35. Is it? Nowhere near. Oh, man. Let's take this again. 17 millimeters. Not 1.75. 17 millimeters. So 16 millimeters is 4 turns. So 1, 2, 3 and 4. So now this is 16 millimeters. And now we need 1.5 millimeters more. And that's 1 millimeter. 0.5 is there. This is now in 0 degrees position and it's locked, and I will be using direct indexing. Let's see about the speed of the drill. Yeah. There you are, 6 holes. Well, I have now cut off the mandrel away from this workpiece because, well, it will not be part of the device. I did cut it with a hacksaw, and you can probably see it's not very straight. It doesn't need to be at this point, so we just make it straight now. I'm going to use the compound for feeding this, and yeah, just doing this manually. A little bit more, maybe. A little bit more. That's it. We are all the way we can. And as you can see, it really pulled all the chips out from there. And that's one nice thing about spiral flute taps, that they do that. So you have less to clean up in the hole. You have some cleanup to do, but not much. There you are. let's try it out, shall we? Yeah, okay. This is the base, and then we have this wobbling thing there, like that, and this is the ring. The output actually goes like there. And then we have this new thing which is going on top of all this, like that. Well, if I squeeze them, I should hear something rattling inside. Yes, definitely. Good. And then just put the screws on. There you are. And it's still rotating. Is there still something loose inside? Yep, there is. Well, then we have the last bit of the puzzle is this thing which goes on top of here. This is how it now looks. That about concludes our this episode of Finno-Ugric machining. In the next episode we start to put this on something where you can really use it. You have been, I know that you have been wondering, how do I attach this kind of round thing to something? Yes, I have been wondering the same thing. But I have a few solutions for that one. I'm happy with this one. Hopefully you enjoyed this simple episode of Finno-Ugric machining. Till next time, see you!